Hi, 6th grade. So in this video, we're going to be covering igneous rocks, and we're going to cover quite a few I can statements in these notes. What you're going to need, though, we're not going to be taking the notes in the outline form like we had been doing. We're going to stick with that graphic organizer. So on the last video notes that you took with classifying rocks, you actually had 2 graphic organizers because we found out that origin was one way that we can classify those rocks. So what I need you to do right now is get out that origin graphic organizer, because we're really going to start to focus on the 3 separate origins. The I can statements that we're going to go over: 10.3, identify how an igneous rock is formed. 10.4, explain the difference between the formation of intrusive and extrusive igneous rocks. 10.5 is classify an igneous rock as intrusive or extrusive and explain your classification. And then 10.6 is going to list 2 different uses for igneous rocks. So we have a lot to go over, but I think as we get going, you'll see that even though it seems like a lot, it'll be easy to organize all the information. So before we jump into the whole discussion of igneous rock, I think it's really important for you to understand when we're studying these rocks, you're dealing with really tiny little samples that are about this size. But when you're out in the field as a geologist, you're going to be dealing with huge layers of bedrock. And I touched on this in previous videos, but I just really want to kind of reiterate that. So what I have for you is a bedrock map of Ohio, and this shows all of the different types of rocks, now that you kind of know the different origins, that are showing up in Ohio. And this is going to talk clear back millions of years ago. We're going to go through all of the different time periods. So when you see the colors are showing what layers of bedrock are exposed, and then down here at the bottom of the map, this is like if we were to take Ohio and we're looking at it on the globe, and we were just to like dig down into like our ground outside and look at all the different layers of bedrock. So what they do is it's called taking core samples. So this is a big drill, and they drill down, 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 and then what comes up are these layers here. So we're actually able to study all of those different layers. And earlier in the year, when I had gone down to Columbus for one of my trainings, we actually got to go to the place where they store all of these core samples. So say that you're an oil company and you're trying to figure out where would be the best place for you to buy land. A lot of times oil companies will come and they'll look at these core samples to figure out if there's a certain type of rock, because we find oil in certain types of rocks. So when we look up close here, we're actually going to see these are all of the different periods, the colors. So all of these colors up to this light brown, which isn't even exposed, all of these layers are sedimentary rock. So we'll talk about these layers once we get to that origin. In order to see any igneous rocks whatsoever, we have to get down to the very, very bottom layers. So when we're taking our core samples, those are going to be the bottom parts of our core. And so when we're doing this, we see that clear, so late Mesoproterozoic, that's before the dinosaurs, and early Mesoproterozoic, that is like at the very, very beginning of Earth. Earth is very, very young, and that's where our igneous rocks were coming from. So I just kind of wanted to show you this to give you an example of how geologists are using and studying rocks in real life. They're looking at those massive layers of bedrock, whereas we're just getting an intro to these rocks, so we're dealing with these smaller samples. So kind of focusing in on those igneous rocks then. Who really cares about igneous rocks? Well, igneous rocks are actually making up majority of the rocks on Earth's crust. So this kind of shows you here what's going on, and we're going to talk about why that is towards the end of the video. But igneous rocks, the reason why we really want to study them is because they allow us to kind of hypothesize about what's happening inside of Earth. We have never been able to reach the mantle, and so by studying Earth's rocks, we can kind of start to make some hypotheses about what's going on down there. we can better understand how volcanoes work, and then it helps us to understand Earth's history. So for example, the great mass extinction of the dinosaurs, they found huge amounts of basalt, which is type of an igneous rock that forms from volcanoes, and they found this in the rock record, or those core samples that they took. So they started to hypothesize that a bunch of volcanoes were actually going off all around the world because they found this in multiple different points. And so they started to create a hypothesis about why the dinosaurs went extinct. So this is why we're kind of studying rocks and why we even have geologists and we want to know about Earth's history. So when we look at igneous rocks and how they form, we remember that we're talking primarily about the crust. That's where we're finding all of our rocks. Right below the crust is the mantle. Now, there are different layers of the mantle, and so we have the upper mantle, and that's where everything that we need for igneous rocks to form are going to be coming from. So this kind of shows you another example of the setup of Earth if we cut Earth in half when we were looking at it. So we see the mantle here, and we see our crust, the oceanic plate and the continental plate. So igneous rocks, they're all formed from melted rock cooling and hardening, which probably sounds really familiar to you on how quartz formed and feldspar formed. And we know that rocks are made up of minerals, so we're going to have very similar environments and rocks forming in similar ways to minerals. So when we look here, we have that melted, or you might hear the word molten, rock. It cools and hardens. So where that's coming from, that magma or lava, and we're going to talk about the difference again between magma and lava. What you can see is from the mantle, this is all of that melted rock. What happens is that melted rock, it's less dense. Liquids are less dense than solids, so they start to rise up into Earth's crust. So we get these large pockets of magma, and then we have lava on the outside. So one way that I remember that magma is underground is the G, stands for underground. And also the tail of the G goes underneath the magma, so it's in Earth's crust or under the ground. Whereas lava, I think of the L being really tall and standing above everything else. And so lava is that melted rock that is on Earth's crust or above Earth's crust. So when we look, in general, we just say igneous rocks form from melted rocks or molten material cooling and hardening, but there's actually two different names for igneous rocks depending on if they form from lava or magma. So there's extrusive igneous rocks and intrusive igneous rocks. And if you use your knowledge about words, you can actually figure out which one would be forming from lava and which one would be forming from magma. If you think extrusive, what words do you know that have the word X in it? Should be thinking exit, exterior. Those are all dealing with being on the outside of something. So extrusive igneous rocks, this is that lava flow on Earth's crust. They're all forming from lava. Intrusive igneous rocks, inside, that's going to be forming from magma. It's inside Earth's crust. So sometimes they'll be inside the actual volcano. We don't always need a volcano though, and we'll kind of talk about that here in a second, some other places where we might be seeing intrusive rocks forming. So let's just go over to our graphic organizer and kind of take a break here, and let's fill that out for igneous rocks. You'll notice that I'm doing everything in red. Igneous actually comes from the Latin word ignis, which means fire, and so it helps me to remember that igneous rocks are coming from melted rock because it's very, very hot. Magma and lava are hot things. So all of my notes that I take for igneous are always in red. So the igneous, it's melted rock, magma or lava, cools and hardens. And then we know that there are the extrusive and the intrusive igneous rocks. So I kind of have those as my titles for my next two boxes below igneous. So let's look at extrusive igneous rock a little bit more in depth. Extrusive igneous rock is lava, which we said is on Earth's crust. It cools and hardens. So there's that picture of your lava for you, so you can kind of get that in your mind. And then what you see here, these are all different examples of extrusive rocks. So I want you to put in, like, what do you notice about all of these rocks? One thing that you should notice is that they're all either black or like a light color. And then when we're looking at the grain size, what do you notice about their grain size? You should think grain size, they're all fine grain or no visible grain. These are actually holes in this one and holes in that one as well. So all extrusive rocks are going to have very fine grain texture. The reason for that is because lava is going to cool very, very quickly. When you think about volcanoes exploding in Hawaii, that water is going to come up and hit that lava, and it's instantly going to cool that lava. And so that lava could cool in the matter of minutes to the matter of months. So we're not giving those crystals a lot of time to grow. So if we go over here with extrusive, it's going to be lava on Earth's crust, cools and hardens. And so we're going to see fine or no visible grain. Oops, I'll give you a little bit longer to pause and get that down in your notes. So then looking at intrusive igneous rock, inside the Earth's crust is the magma. So that magma, it cools and hardens. Does the same exact thing as lava, the only difference is where these rocks are forming. Now, this is inside a volcano, so these, and you can kind of see some of that magma flow is kind of branched off and it's starting to cool and harden. Sometimes we don't have a volcano at all. There's just a pocket of magma that forms deep within Earth's crust, and it makes a huge, huge kind of pool of magma. And over millions and millions and millions of years, it'll slowly cool and harden. So that's a big difference that we're seeing between magma and lava, not just the location, but how quickly it cools. And so because we're giving it those mineral crystals so much time to grow, we're giving them millions of years to grow, we start to see a lot larger crystals. So if you look at these 3 samples of igneous rocks, you're going to see large crystals in all 3 of them. So that's one clue when you're looking at rocks. If you're seeing large crystals, it might be an intrusive rock. If you're seeing fine grain crystals, it's probably going to be an extrusive rock. So coming back over here then, with intrusive, it's magma in Earth's crust, cools and hardens, and so we're going to get that coarse grain for our texture. Now, I showed you a lot of different rocks, but I didn't give you the names because you're actually going to get to do that in your next lab. You'll get to explore their names, and you have to identify if you think they're intrusive or extrusive. So it's important to kind of keep in mind what our main characteristics are of intrusive and extrusive rocks. And then after your lab, what you can do is you can go back to your notes and fill in some examples of those intrusive and extrusive rocks. Talking about igneous rocks around the world, because we are studying these tiny little samples, I want you to kind of get a view of where geologists would go to study huge samples of these exposed rocks. The Hawaii volcanoes, you're going to see a lot of basalt. That's what volcanoes are usually made out of. Another place that you can go is called the Giant's Causeway. It's in Ireland. These are also basalt, and they look like stepping stones. Another place that you can go is actually in the United States is Yosemite National Park. All of the mountains there are made out of granite. So granite, basalt, these are some common igneous rocks that you're going to hear those names a lot. And then Mount Rushmore in Black Hills of South Dakota, that is also a granite rock right there as well, and so that's what they carved those out of. And then some of our igneous rock uses, granite is used a lot of times for countertops. So if we think about granite, and we know its mineral composition, it's made up of feldspar and quartz. That's its primary 2 minerals. And if we think back to most hardness, feldspar has a hardness of 6 and quartz has a hardness of 7. So this is going to be a very hard rock. And when we are making countertops, we want something very, very durable. Also, these minerals were made in high heat, so granite does well when it's exposed to high heat. So if you would accidentally set down a hot pan straight off the stove, you're not going to damage your countertop like you would if you had something like Formica, which is a man-made material. Another use for granite is because it is so hard, it's very difficult for it to be weathered and broken down, and so we'll use it for a lot of our monuments. So when you go to Washington, D.C. as an 8th grader, you'll get to see the Washington Monument, and one of the rocks that they use for that is granite. And then when we go to Put-in-Bay in May, the Perry's Monument, it's actually made out of a red granite. So I gave you two different ways that granite could look, and these are a little bit more fine-grained. So we're knowing that they didn't cool as long as the granite that we were looking at for our countertops. That granite would have taken millions of years to form, which is why we see granite being more expensive, because it does take so long to form. Another igneous rock that we talk about is obsidian. And obsidian is very, very sharp. It's actually another word for it, or another name for it is lava glass. So in ancient times, Mayans living in Mexico, they were around an active volcano at that point. They would actually be able to find obsidian all over the place. And so they used that as arrowheads. Now, our Native Americans, there wasn't a volcano in Ohio. So instead of using obsidian, they used a sedimentary rock, which is flint, to make our arrowheads. So it's a little bit different areas of the world where we're seeing our Native Americans use different rocks for different tools. Obsidian cools so quickly that there's no time for minerals to form at all. So this rock is actually not made up of any mineral crystals. Currently, we still use obsidian for scalpels, and so in case you can't see this, it says on the cutting edge. In the 1970s, doctors performed open heart surgery on Donald Crabtree, who's an archaeologist, and he wanted them to study using steel scalpels and obsidian scalpels fabricated by this archaeologist, and the incision from the obsidian blades healed with hardly a trace, while the steel blades left huge scars. And obsidian blades can be shaped to a width of nearly 1 molecule. So extremely, extremely sharp, and this was 5,000 times the magnification, the steel scalpel versus the obsidian scalpel. We actually still use obsidian in our surgery tools when we're doing LASIK surgery, or well, not LASIK, sorry, that's a laser, but when they do surgery on eyes, they'll use obsidian because we need extremely sharp scalpels for that. And then the last rock use that we have here is pumice. Pumice is a very interesting igneous rock. We're going to talk about it in our conference after you check your understanding. It's very, very coarse and rough, and so we use it with a lot of beauty tools to help get rid of our calluses. You'll see women take for pedicures, they'll rub it on your feet to get rid of all of that dead skin. They use it as an exfoliant a lot of times to get rid of that dead skin. So I know this video is a little bit long. It's tough to get all the information in with igneous rocks, but if you have any questions, let me know, and we'll talk more detail about igneous rocks once we go through your lab and after you check your understanding. So check your understandings are going to be a little bit different. It's kind of just to see what you're grasping from each rock section, and then you're not going to take a quiz over igneous rocks. At the end of your entire to-do list, you'll have one big check your understanding where it'll kind of review all of this stuff, and that'll tell me if you're really ready for a quiz or not. These check your understandings throughout your rocks to-do list are really just reviewing the important content that you should have gotten through your labs and activities.